All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 3, SLT23. This lesson in this video is about graphing rational functions with transformations. We're going to first start with connecting these equation forms into the transformation form. 1 over x minus 5 is the same as f of x minus 5. 1 over x minus 2, as you can tell, just links right here to f of x minus 2. And 1 over x minus 4 is the same in function notation as f of x plus 4. So you can see that they are very similar in the way that they are written. Let's talk about transformations. Now, when you have a rational function, you're going to have both a vertical asymptote and a horizontal asymptote. And where those two asymptotes meets creates what is a new origin. So you have the old origin, which is right here at 0, 0, and you've got your new origin created by your two asymptotes. Now, if you look at the old origin and you look at the new origin, you would say to yourself, well, it looks like the origin has moved 2 to the right. Now, how can I write that as an equation? So I'm writing that in asymptote form is what I like to call it. So I'm going to write 1 over x minus 2. Now, you're probably thinking, well, why is it minus 2 if it shifted 2 to the right? Well, the denominator always ends up being the opposite of what you would normally think, kind of the same way that anytime you've done transformation forms, like when you did quadratics, anything that was inside the parentheses, x minus h, ended up meaning left or right, being the opposite of what you would normally think. So the same goes for the denominator in a rational function. It's always going to be the opposite of what you would think. Now this time it moved 1, 2, 3, 4 to the left. And anytime the function moves 4 to the left, then it's going to be 1 over x plus 4. So it's this one right here. And the only one left is 1 over x minus 5, which is on the next slide. And you'll see that this one's been moved 5 to the right. So this function is 1 over x minus 5 because it's moved 5 right. Now, whatever's on the inside, like I said, is always the opposite of what you would think. So f of whatever this letter is going to be the same letter that's right here because it's x minus c. So it actually means it's the opposite of whatever c is. All right, now we're going to talk about the numbers that are on top, the numerators, not the denominators. The numerators in this case, so all three of these equations all have the origin has not moved. It hasn't moved up, down, left, or right. But what has changed, and if you look at the parent function 1 over x, is that the function has spread apart from the origin. So it's dilated is the word that we use. So it's moved away. So the bigger the number, the further it gets away from the origin. So in this case, if I go to the very next number, which is 1, I'm looking at the x-axis. The next number is up 1, 2, 3. Looks like it's up 3. If you go right 1, you would have to go up 3 to get back to the function. So therefore, the numerator is 3. So whatever the height is of the next number always tells you the numerator of the rational function. And this will just be 3 over x because there is no left or right and there is no up or down, which I'll get into on the next slide. This time, notice that this is the parent function. Notice that this is quadrants 1 and 3. Now we have quadrants 2 and 4. So everything has been reflected over the x-axis. And if that's the case, then their numerator has become a negative because the next number is actually down 1. So this is negative 1 over x. And this one is also down, but it's down 1, 2, 3. It's a little hard to tell. Is it 4? I guess it's 4 because that was the choice up here. So this is negative 4 over x. All right, now the third thing that you need to keep in mind with transformations is the k. So this is the h, this is the k. The k in quadratics always move the function up or down. So when you look at this equation, you're saying it moves right 1 and up 1. So I'm looking just at the origin. So if this is the origin, right 1, up 1. This is not where the two asymptotes intersect, so that's not it. This one is right 1, up 1. Okay, can be this one because that's in the correct spot. But then the numerator is 1. The next number is 1 above, and that looks to be the correct answer. All right, and then I look at h, 1 over x. Minus 1 means it's translated down 1. So instead of the origin being here, it's been moved down 1, and the next number is 1 above. So that would be this one, 1 over x minus 1 for down 1. And then the last one by process of elimination, this says left 3 and up 4. Left 3 and up 4. Remember, this is left 3 because it's always the opposite. Up 4 exactly what you would think it is, and the next number looks to be about 1 above. So that's 1 over x plus 3, and then the plus 4 on the outside. All right, so that pretty much goes over all the transformations that could occur for rational functions when the degree is 1 on the bottom. So what about when the degree is 2, like we did in the prior video? It's basically the exact same thing. So when it's x minus 3 squared, that still means right 3. So this is right 3, this is down 4, and this just means the next term is going to be 2 above it. Right 3 down 4, it looks like j is this one. And then the next term is 1 above it, which it is. So this is the, 2 above it, sorry. The next term is 1, 2 above it. It's really hard to tell because it's a small graph. So this is 2 over x minus 3 squared minus 4. Now remember, this is an even degree. Now, it's not necessarily an even function, although this one is right here because it's a perfect reflection of the y-axis. But now that we've done a transformation, see the vertical asymptote is actually shifted to the right, and therefore these two pieces aren't perfect reflections over the y-axis. So therefore it's no longer an even function, but it does have an even degree, which is the reason why it takes up what would be the first quartile and the second quartile if you consider this the new origin, considering this the origin. The next one just means it's -1, means it's going to be both pieces are on the bottom. It's been reflected over the x-axis. And it's going to look just like the parent function in every other way. So that's this one. So it's -1 over x squared. Or you could put x in parentheses, it wouldn't matter. The next one is also going to be facing down because it's -3. It's going to be stretched out. In this case, as you can clearly see, it's further away from the origin because of a 3. The next point's going to be 3 below. It's also been moved 4 left and 5 up. 4 left, 5 up is where the two asymptotes intersect. And there you go. So it's just looking at an equation. You're just reading it piece by piece. The top number, remember, tells you the dilation factor. The bottom number tells you the transformation left to right. And the outside number tells you the transformation up or down. And the fact that it's squared on the denominator just tells you that this is an even degree, which means that both pieces of the rational function are going to be side by side, whether or not they're both on the top of the vertical or the horizontal asymptote, or if they're both on the bottom side of the horizontal asymptote. All right, look at the graph below. Y equals 1 over x. That's the parent function for all rational functions with a degree of 1 on the bottom. This function has slid down 2. And the next one is 1 above. So that would be 1 over x and -1 for the down one. There is no transformation left or right. This transformation moves left 2. So I know it's going to be x plus 2 on the bottom. And the next number is 1 above, and it is also slid 1 up, because if you look at the origin, here's the old origin, here's the new origin, it's slid 2 left, that's right here, and 1 up, which is right here. This one has slid 1, 2, 3 down, so I know it's going to be -3 on the outside. Remember, this function is down 1, so it's going to be -1 over x. There is no transformation left or right, so it's just -1 over x. Now, you can go -1 over x -1 or +1. That doesn't matter. I'm sorry, that absolutely does matter. Sorry, I had 1 in my mind here. You can do x -0 or +0 because that's the same thing as just x. X plus nothing is still x. X minus nothing is also x. So you could write the answer out just like this, and that would be the exact same thing. Look at the parent function, write the equation to the graph. Okay, same thing as we just did. So it looks like the new origin is right 3 down 1. So that's going to be x minus 3 on the bottom and down 1 on the outside. And the next point is 1 above. So there's your numerator. This one looks to be just moving 4 up, so I know the outside is going to be 4 up. The next point is 1 below, which makes this -1 over just x because it does not move left or right. And last one, 1, 2, 3, 4, up, right 4, up 1, so that's right 4, up 1, and the next point is 1 below, which means that the numerator is -1. And I think that pretty much concludes it. Please feel free to ask me any questions in the comments area if you have any questions. And give it a like if it helped you learn something about graphing rational functions with a degree of 1 or 2 in the denominator and using transformations. Thanks again for watching. Have a great day.